Hi everyone, my name is Nick. I'm software developer and core contributor of OneInch network. And today I'm going to talk about mastering the app development with OneInch developer portal. So let's start. So let's do some small recap before I will be talking about developer portal. Maybe some of you don't know what is OneInch, and let me introduce what is our company, what is our project. Basically, OneInch is a leading protocol in DeFi DeFi space, in the blockchain space. And over the last 3 years, we do have about 4 million users. We do have about 55 billions of available liquidity in US dollars that are available to swap. We do have about $355 billion volume that got through OneInch for over 3 years. And we have about 70% of aggregation market share, what is the main share, main market for our company. So we are the leaders of this market. And also we are actually the first DEX aggregator that was invented. So we are not only the leaders of this market, but we are the company who actually created this industry at all. So actually, maybe some of you have some questions about numbers that we do have, and just want to add a small comment that all our analytics, all numbers that we do have is available on dune.com/oneinch. It's basically a product that allows to track all users' analytics, all actions happening on chain. So if you have any questions about numbers that we do have, it's completely transparent. We're taking care of that. And you can just go to the Dune Analytics and take a look how it's actually executed, what is the queries for that. So it's pretty transparent about what we all our numbers are pretty open and on chain. Okay, so over the last couple of years, we built multiple protocols and solutions, and right now we do have several of them. The main one is actually aggregation protocol. It's the first protocol that we have built. It's actually the protocol that allows you to swap token to token with the best rate on the market. The second one is the limit order protocol. It's actually an extension of DeFi trading features. It allows you to create limit orders off chain, but executed on chain. We do have a OneInch Fusion. It's a new invention that allows you to swap gasless with MEV protection on multiple EVMs, and also allows you to have almost the best than on market rate for your trade. And we do have a non-custodial mobile wallet on Android and iOS. And right now we also do have a developer portal that's mostly focused on developers. So let's talk a bit about developer portal and what is it. Over the last 3 years, we built actually a trading API that allows users to trade, and we got about, as I told before, we have billions of dollars going for us. So we have a battle-tested API, and we just came to an idea that during our development, we made several APIs for internal usage and several APIs for public usage. And over these years, we decided that maybe it's a good idea to open these APIs to the public to allow developers to build on these APIs, because it's battle-tested APIs that allows you actually to trade and to create any dApp. And I will be starting to showing some examples soon and talking about these APIs. But the main point here is that with such APIs that we have right now, you can build your own dApp, and the best of it is that right now we have a public plans with pretty interesting solutions that are battle tested, and some of them are pretty unique. And let's start from this is actually how developer portal looks like. It's called. I will have some links soon, so you can try it out online. Basically, just classical dashboard for developers that allows you to get an API key and query any API that we have with this API key. And also you have all analytics and all necessary for your project to set up it and take a look on what requests you're making and how to update it, upgrade it, or analyze what is your activity there. Okay, let's focus on Swap API. It's our main API that we do have. It's actually part of aggregation protocol, and I want first to talk about it. So basically, Swap API, it's an API that allows you to make on-chain trade with Uniswap-like experience, but with pretty advanced strategy, how it's actually executed. The main difference between Uniswap-like experience and Uniswap, for example, and OneInch is that OneInch aggregates Uniswap and multiple other DEXs together. So let's imagine we have a use case, like a scenario. You want to swap some OneInch tokens to the DAI. How it's executed in case of OneInch? Basically, we build a path It's actually a path that goes through multiple pools, multiple tokens, trying to find the best rate at every pool. And the idea is that if you will try to make direct swap, for example, from one inch to DAI, the rate will be not the best one because of the price slippage. Usually, if you have a large amount of tokens, you need to split this amount into multiple parts and try to swap this money across multiple pools at the same time. And that's what actually one inch do with swap API. It basically generates the most optimal path to make a swap, and all of that actually is happening atomically. So this is actually one atomic transaction, but in this transaction we do have a swap from one inch to wrap Bitcoin, after that to wrap to USDC, and only after that to DAI. And as you can see inside, there are sometimes multiple protocols in the same token. So actually we don't swap not only wrap Bitcoin to wrap USDC with one exchange, we swap it with multiple exchanges. So we aggregate not only split it, we do have some splits inside and every split we do have. So if you're talking about developer experience, how to build on it, how to use Swap API, it's pretty simple. We do have actually two things that you need to do. It's basically we have two API handles. The first one is actually called quote. The second one is actually called swap. And firstly, you need to make a quote. If it actually returns you the exchange rate, the return amount that you want to swap. For example, you want to swap some 1 inch and to DAI. If I will make a quote for that, I will get some return amount of DAI that I will get if I will make a swap, if I'll execute the swap. So, first you will make a quote, and if you're okay with this amount, if you actually got information that you're okay with this rate, with the amount that you will return, you need to execute the second handle called swap. And the swap handle actually will return you a call data. Call data is actually a data that you will need to, is a necessary data that you need to build a transaction and send this transaction with your private, sign this transaction with your private key and send it to the on-chain, basically send it to EVM, any EVM, like for example Ethereum. We actually execute all transactions with one inch router on-chain. So basically the idea here is that you will build execution data with us and execute it on your own. So it's quite simple for making advanced swap. It's just two handles with very simple parameters inside. So let's discuss these parameters, how to use, for example, quote handle. Idea here is pretty simple. You have three parameters, three necessary must-have parameters. It's from token address, to token address, and amount. I think it's not necessary to explain what is it. You just need from token, you just need two tokens, and amount you want to swap. And after that, you will get a return result. However, we do have some advanced parameters for such API. And I wanted to take a look a bit on it. We have multiple additional queries that sometimes it will be usable for you. For example, we do have a query called protocols. It basically allows you to specify which types of DEXs you want to have in the swap. Sometimes you want actually to make a swap not across all the DEXs, but across specific ones. Let's imagine you want to swap only with Uniswap v2, for example. It's possible with specifying the protocols. By default, we do have all of them, but you can specify them, yes. And we do also support a fee. So basically, if you are integrating your Swap API to your product, for example, to your wallet, and you want to get some revenue fee sharing, we actually support that, and you can specify the fee percent. For that, you will not only need to specify the fee percent, but also the fee address, the collector of these fees. And it can be up to 3%. For example, it can be 2. By default, it's 0. So if you want to specify the fee, you need to take a look on that as well. And another parameter that we do have is actually connector tokens. It's quite advanced thing. It's actually, as you see on the previous slide, when we have a swap from 1 inch to DAI, we have multiple tokens between. Actually, we call them connector tokens. In that case, it was wrapped Bitcoin, it was wrapped Ethereum, and there was USDC. So sometimes, in several cases, when you do a swap from non-liquid token to liquid token, there are some liquidity pools that are very unique and not very popular. And if you know these liquidity pools with these specific tokens that have enough liquidity and are not tracked automatically by 1 inch, you can specify it manually. In some cases, if you will specify connector tokens on your own, you will get a better rate. It's usually actually corner case scenario. Usually it automatically works well. However, if you're launching your own token, for example, and you know some liquidity pool that is not really public, you can specify it here. for the connector tokens. And another parameter is basically gas price. I just want to mention that Vanich algo is pretty smart, and we trying to get exchange rate. We are basically trying to calculate the path based on the gas price that we have on the chain right now. So I mean that, let's imagine we have extremely high gas price right now. And if the gas price is extremely high, that means that in some cases when you swap a small amount of tokens, it's actually not economically okay to have a complex path. It's better to have a less return rate but pay less for the gas, because every swap with every protocol is more gas expensive. So the simpler path is, the cheaper it is in terms of gas computation. So this is example of complexity level parameter. It's one other parameter that actually allows you to specify how many steps we have for the swap. So basically, in such case, it's by default 2, and the maximum amount is 3. It's actually it can be up to 3. You can't specify strictly that it will be 3. However, it will allow the API to be up to 3. The problem here is that depends on the complexity level. There will be different types, different response rates. So in some cases you need to have a very low latency, and in these cases you need to specify complexity level 0, for example. It also depends on the gas price and the gas computation. So another parameter that we have is actually called main road parts. It's quite important parameter because it specifies the maximum amount of splits for the from amount during the swap. So for example, in such case of the die, we will split it for the maximum 5 parts. And every road will have its own path later. So like by default it's 10, it can be up to 50, but if you specify it as a 50, you will have some higher latency because of more computation, actually. And we do also have another parameter called parse. It's actually a max amount of sub-paths for every path. So basically you can also specify that, and it can be up to 500. So in such case you can potentially have extremely complex part, extremely complex swap, and extremely complex call data. But sometimes it's useful, for example, in the cases when you swap extremely large amounts of tokens. So actually we finished with the quote, and with all potential parameters that we have there for the API, let's try to take a look on the swap API. Basically, the swap have the same handles, the same parameters and quote, like from token amount, to token amount, and amount, but there is only one more necessary parameter that we need to specify to make it work. It's called slippage, and it's one of the most important parts that I recommend to focus on. Basically, slippage allows you to specify the amount of the percentage of tokens that you will lose potentially during the swap. Why it's happening? Sometimes during the on-chain activity, when you make a swap, when you sign transaction and send it to the blockchain, it's not verified yet. And when it's not verified yet, that means that it's not yet executed. And during this execution time, the rate can be different. Let's imagine right now the rate is 150, and during the execution of this block, the rate can be up to 200, for example. So the difference can be so serious that you can potentially lose too much money, and it will be not profitable for you to execute such rate. And such thing, it's possible to control such thing. It's very hard to predict how rate will behave during the execution of the transaction, during the mining of this transaction. So for that, we do have a slippage parameter. So basically, when you specify it, you actually calculated your minimum return for your transaction when you're executing that. And it can be up to 50%, but I strictly don't recommend to make it 50%. By default, we have automatic protocol that specifies the optimal slippage for every token pair, and so you need to take a look on that. And I also do not recommend to specify it as a 0 or like 0.1, because sometimes if you will have too low slippage, every time you will execute the transaction, it will be reverted, because you actually potentially got lower than you specify. So there are some additional parameters that we do have at Swap API. So let's talk about them pretty fast. One is actually destination receiver. So if you want, for example, to make a swap from address A, and you want these funds to get to another address, for example, to address B, you can do it inside one transaction, so you don't need to do another transfer. And for that, you just need to specify destination receiver. For example, I'm swapping some tokens and I want to send it directly to the exchange or to someone else, to my friend, for example. And we do have a referral address. It's basically part of the fee program. So basically you specify a referral address and the fee amount at the same time if you want to get some rewards from the fees. And we do also have a permit. It's basically the default parameter for every swap, and you have for the token that supports permit. It's basically permits actually is functionality that allows you to make off-chain signature and make a bundle transaction with this off-chain signature that have allowance inside. Allowance is a necessary parameter. It's a necessary thing that you need to have for the token to make a swap. Every year, sometimes the token have a lot. Like you need to make a proof for one each router if you want to make a swap, and you can do it inside one transaction right now with permit. And we do also have a gas limit. It's basically the same thing as a gas price. It's about the amount, the limits that you have for the computation. Depends on them. One each will be one each algo will adjust the swap path. And another interesting parameter is called allow partial fill. So it's pretty easy to visualize that. In some cases, when you have a swap, we split it into multiple parts. And let's imagine there are some cases when some parts are going through, but there is one part that actually fails. The reason for that is that the exchange rate in this part actually is not any more attractable for you. And sometimes you still want to execute such transaction with the best possible rate, but the from amount will be just a bit lower, so it will be returned to your address during the same transaction sometimes. If you want to specify, sometimes it makes sense if you want to swap really fast with the best possible rate, the best maximum amount you can swap. And we do have another important parameter called disable estimate. This parameter, if you will specify it as a true, it allows you to estimate some transactions that potentially can be failed, but it's failed because you actually know, like there are, for example, no any tokens on the address. By default, if you will query swap API, we will try to estimate transaction for you. So we will try to emulate that it will be working on chain. But if you actually knows that something is wrong, but it's planned. For example, you have a query, like you have a quote for the smart contract, not for the address. You need to specify disable estimate true. So the main use case for that is basically when you do have a not externally owned account, but a smart contract wallet, for example. So yeah, actually, this is how you can try it on the One Each developer portal. It's basically several handles. I want to go through some of them as well. So if you will open it on the website, we will have swap quotes, approved quotes, and info quotes. So basically, swap quotes is all necessary what you have, but we have additional quotes for the approved and for the info. The approved part is basically allows you to get allowance of the token you want to swap. It's some preparations you need to do before you will make a swap. Because if you have some ERC20 token, but you don't have allowance, you need to make it. You need to make a proof on the One Each router for this token from the user side. So it's sometimes additional transaction. So you have all necessary handles here to actually start swapping. Yeah, it's some of them. Let's try to actually take a look how it works. This is example of execution of quote handle. As you can see, it's only one parameter here. It's a to amount. It's quite simple. So it's actually nothing to talk about. So it's pretty easy to try it, even online. Okay, we actually talked about swap API, and I want to focus on another API that we do have. It's actually limit order protocol, and let me first discuss what is it. So before we were talking about instant swaps on chain, let's imagine that the problem of that is that it is instant, but we have some issues with the rates sometimes. Let's imagine that you have enough time, you're okay to wait, but you want to specify the rates and you only okay with swapping only with this rate. Let's imagine I want to sell my Ethereum only with $2,000, like 2,000 per day, and nothing else, and not any other rates. So with limit order protocol, you basically can specify that. It's basically creation of limit order with such rates, and Vanish do have it for a couple of years. And additionally, on top of the limit order protocol, we have multiple other features. Some like, firstly, it's gasless for the user. So when you create a limit order, you basically don't do any blockchain interactions. You just create a special structure and set it to 1 inch, and it will be executed without users' Ethereum native token. The second part is that we do support, managed limit order protocol supports multiple things like NFTs, for example. We do have a custom predicates. We do have precondition and postcondition hooks, like interactions, and basically with that you can have a dynamic pricing. You can have a custom price formula for every swap, for every order. So it's actually a Swiss knife of everything we have. So let's try to visualize how it works. Basically, we have two entities here. The first one is a user. It's basically a person who is trying to swap. User needs to do several things. User needs to create order, sign it with the private key, and submit this order to the 1inch API. And we do have another entity. Actually, you can try it actually online. We do have support of limit order protocol on the front end, and with that you just sign the order. You don't send it to the blockchain as a user. So you don't pay for gas in such case. And we do have another entity that actually executes the user's orders. It's called market. It's actually market maker sometimes. It's sometimes arbitrage bot. It's sometimes 1inch aggregation protocol or other user. It's basically other entity that collects all these orders. For example, I create a limit order to sell some Ethereum for the DAI, and there is another entity, like person, who wants to execute such order. In such case, if you want to make it, you need to connect to 1inch API or to get this order, basically. When you will get it, you need to verify such order, to verify that the exchange rate is okay, the amount, the balance of user is okay on the other side, and after that, you need to fill this order. For such thing, you need to pay. Basically, you will make a on-chain transaction in such case. This is actually the basic scheme how it works. So as you can see, firstly, the user create an order, and after that it goes to the database, and market takers can get this order from the database and execute it on chain and pay for that. The moment here is that because we need to pay for the gas for executing the order, the exchange rate depends. The exchange rate is fixed. Sometimes, even if the price is better than the rate that we have in the limit order, it's not executed really instantly. So the problem here is that because it's off-chain limit order protocol, we don't have a centralized matching engine, and any entity can execute orders. Basically, it depends on their own billings, and only if it's profitable, it can be executed. But there is no any strict guarantee when it will be executed. So you can actually try limit order protocol at Vanish Developer Portal as well. And as you can see, we have multiple handles here. The first one with the post method allows you basically to send your own limit orders to 1inch database. So if you want to share your limit orders with 1inch, and basically it's the simplest way how your limit order can be executed. Basically how you can create your limit orders is basically sharing it with API. It's just basically a JSON transaction. It's quite simple. We do have an SDK for that. And all other handles that you can see here is basically allow you to get information about all orders that we have in database. So basically you can run your own arbitrage bot, for example, and fill limit orders there as well. So this is example of, for example, a list of all limit orders that we do have with pagination. So basically it allows you, for example, to get such order and check at the rate. If the exchange rate will be profitable for you can execute it and get some profits on you. Okay, so we discussed the limit order API. It's one of the aggregation API right now. It's one of our oldest APIs, and we have them for years. However, we don't have, and we build them based on multiple other APIs that I'll be talking about right now. It used to be internal APIs, and right now it's public. The first one is called Spot Price API, and what is it? In some cases, when we do some swaps, when we have an interface, we need to show some fiat amounts of every token. For example, we need to show a fiat amount of Ethereum, fiat amount of DAI, and every other fiat amount. And actually, it's a quite big task and issue how to show this fiat amount, where we can get this data. Because if we will have not a proper data, user can have, we can lie to user, and user can lose money. Let's imagine we have some not liquid token, and we will try to show the price that will be a bit not updated, a bit outdated. And the price can be instantly changed, and user can lose a lot of money because of that, because user is used to think that the price was much more higher, for example, but right now it's extremely low. So we need to have an API that will be extremely fast, will have a lowest possible latency, and will be extremely transparent, like to verify that this is the real fiat price of the token. And it's actually a big issue how to make it. How to get a fiat price, how to get a native price, like how to get the price of any other token on chain and make it transparent. For that, we do have a project called Spot Price Aggregator. What is it? Basically, we use on-chain data to get any price of any token based on their liquidity pools of multiple protocols, like Uniswap, for example. So if you know, for example, that we do have a token, and we do have a token in the blockchain deployed, and we do have a liquidity pool there, based on the liquidity pool rates and weights, we can actually get info about its exchange rate for another token. And if we will combine multiple paths with multiple pools, and we will actually can build exchange rate for any token. For example, you can get information about fiat rate of the DAI, or like fiat rate of Ethereum based on exchange rate from DAI to Ethereum. And yeah, so it's quite simple. It's open source, and you can actually use it on your own projects. We do have actually information about that in GitHub and on the website. And the idea here is that we aggregate all information across multiple liquidity pools at Uniswap, V3, and V2. So actually the results of every API response of spot price is actually quite transparent, and you can verify it on chain. The problem here is that we call this actually off-chain oracle. It's actually the oracle to get the fiat prices. But I do not recommend to use this off-chain or oracle for your inside Solidity, inside on-chain, because the issue here is that we calculate the exchange rates in every block, and it can be completely different, depends on the situation happening in this block. So it's quite okay to use it off-chain, but inside one chain you can get hacked, for example, for using such oracle. So it's specifically the main purpose is off-chain usage here. So spot price API have actually quite a few handles, and let's talk about some of them. So the default one is v.1.1/1 is actually the one is actually the chain ID, and with that you will get the fiat prices of multiple tokens that we have in the default list of OneInch. We have a default list of OneInch tokens, about 1,000 tokens on Ethereum, for example, and we'll get the fiat prices of all of them with one request. So this is how it looks like. This is like the response for such request. The beauty of it is that using spot price API, you have almost the lowest latency, not only with the response of this API, but with the on-chain data. Basically, that means that all this data is traceable, trackable, and transparent, and it's okay to show it to the user because actually we know the source of this data. We can prove that this data was calculated from Uniswap pool. We don't get it from anywhere else. So that's how we actually handles all the fiat prices, not only in the OneInch dApp, but also with OneInch mobile wallet, for example. So if you, for example, are building something where you don't need to have a fiat prices and you want to have a transparency, Spot Price API, I think it's the best tool for you. And I can just mention that we have support of any token, any ERC20 token across 11 EVMs. All EVMs that we do have support at OneInch. So let's talk about Balances API as well. As you can see, this is actually a screenshot of a wallet, of a OneInch mobile wallet. As you can see, any wallet do need to have a balances of user wallet, of user tokens. And we do have a balances API that we use that's inside mobile wallet, and sometimes we do use it in a OneInch dApp. So basically, if you sometimes need to query a balance, you can use this API. What is the main reason to use it compared to implementing something on your own? There are multiple problems here. When you query a balance of every wallet, there are sometimes issues with the latency. Also, there is issue with querying multiple balances of multiple tokens. Sometimes, if user have, for example, 1,000 tokens, if you will do default implementation of querying the balances, you will need to make 1,000 queries for 1,000 tokens. So it's a lot of API calls. It's extremely expensive. It's extremely long waiting. It's actually a lot of problems with that. So user experience will be actually quite painful, and it will be also quite expensive for you. And another problem is that when users have multiple tokens, sometimes it's multi-chain logic. So like user have some tokens on Polygon, some tokens on Binance, some tokens on Gnosis chain, for example. And if you want to show all of that, it's quite problematic. You need to support all the nodes. You need to maintain all these all the JSON RPCs across all chains, multiple chains. It's extremely resourceful. And compared to that, at 1inch, you just have one simple API call with multiple parameters. You don't need to think about JSON RPC methods. It's extremely optimized. It's just one simple API call. So it's much more cheaper and faster and reliable. This is how the balances API handle looks like. And I just want to mention there are multiple methods here. The first one is actually, as you can see, it's aggregated balances and allowances. And what is it? In some cases, when you do have when you check balances, it's also sometimes useful to have information about allowance for some things for the user. Let's imagine, for example, I want to make a swap. The main logic, the main flow here is quite simple. I want to make a swap, and during a swap, as a developer, I want to get the balance of user. So I will check that the user have enough resources to make a swap. And also at the same time, I want to check allowance of the user to make a swap for the 1inch contract, for example. So it's actually, that's why we have aggregated a bunched handle that allows you to return allowance and balance of user in the same response. It just simplifies the user experience. And if, for example, you want to make you want to build a wallet and add 1inch swap functionality there, you can also use such handle. And we also do have a quite simple handles as well. Like default ones are balances. You just need to specify a wallet address and the chain ID, and with that you will get information about all users' tokens and their balances. By default, we do check about thousands of 1inch whitelisted tokens and the information about their balances. But if you want to know about custom balances, about custom tokens that are not listed here, you can also specify it with the post requests. You can specify any amount of token there and get their balances with one response. So this is an example how it looks like. This is, for example, a balance of Buterin for some tokens. Okay, and let's talk about token API. So, as we were building the dApp, we need to somehow to show the user tokens, like all possible tokens that users can potentially have or want to swap. And it's actually not a simple. It goes pretty simple, but there are a lot of multiple features inside it. The tokens API allows you basically to have information about all listed tokens that we do have, and information about almost any ERC20 token with, like information about its decimals, about its logo, about its name, all on-chain data, but using just Web2 API. We do support multiple features inside tokens API. The first one, we do have a text search. So if you want, for example, to implement a text search across multiple tokens, allow user to find a specific token. You can use tokens API. This text search actually is optimized. We do have an internal rating system for that. Basically, it's based on amount of. It's basically linked to the one Uniswap token list and amount of this token and popularity of this token across multiple protocols. So, for example, if your user is searching something for the DAI, it will be a lot of responses. But there is only one DAI token that is really most popular one, and we do have it in multiple protocols. So we actually have a rating system there. So it's also quite a nice user experience. We do also support a Uniswap token list protocol. It's actually a token standard that allows you to declare a list of tokens that you want to support with your dApp. And we have a response styled in this standard. So basically, you don't need to take care about, if you already use a Uniswap token list, you can just simply switch the API and have support of multiple token lists. They aggregate about 11 token lists of multiple projects. So if you want, for example, to use not 1inch token list, but CoinGecko token list, it's possible with 1inch tokens API. So let's continue. And as you can see, the API, the handles for the tokens API are also quite simple. Basically, it allows you by default to get a list, and you have a search query, and you have a custom handle. Custom handle allows you to get information about any ERC20 token just by address. It's basically quite a big problem sometimes to get information about a ERC20 token. I mean, it's decimals, its name, its symbol. Let's imagine when you have a bunch of them, for example, 1,000 of address, and you don't know anything about such addresses. It happens sometimes when you do some trading, you analyze the the call data, and you have information about the addresses, but you don't know any information about decimals, about the name of these tokens, and it's a must-have if you want to make another swap, for example, if you want to make an arbitrage. And sometimes you need to get information about all these tokens instantly inside one request. And if you will try to use, for example, JSON RPC to get such the same data, it will be also not a bundled request, it will be multiple requests. So for the 1,000 tokens, you will have 1,000 requests. It will be extremely long and also extremely expensive. But in one each case, you will just make a simple one API call with almost extremely low latency, much more lower latency than you will do with JSON RPC. So this is example of query of one each token list for the one each provider. So it will be a list of all tokens there with all information, with all logos. So you don't need to aggregate and get this data from anything else. It's extremely useful for anything that have tokens functionality, basically. And we do also have a portfolio API. I think it's a small teaser of our new product that will happen maybe soon. Portfolio API allows you basically to do several simple things, but the main one is get P&L of multiple of user by multiple tokens on chain. So it's really hard sometimes when you have multiple tokens to get information what was your profit and loss for example for 1 year. And with the portfolio API it's possible. We do use only on-chain data for that, and in DeFi it's almost like one of the most unique experiences you can get with the portfolio tracking. And another thing that we do have here is actually charts. The problem that multiple apps have with the charts is that all the token price charts sometimes are not actually real data. It goes from Binance, for example, or it goes from CoinGecko. It's sometimes outdated, or actually it's not linked to the DeFi market. So we actually decided to build charts based on the transparent data that actually goes only from the blockchain. And with Portfolio API, you can get information about fiat price of any token based on the on-chain data, not from Binance, for example. So there are actually a lot of handles for using Portfolio API, depends on your use case. But the default ones is actually the tab called Portfolio. Most of the necessary handles are there. For example, a profit and loss and a value chart. And yeah, this is like the simple request for getting P&L for Vitalik Buterin address, for example. As you can see, the response is quite simple, and yeah, it's quite fast as well. And the last but not least, it's a traces API. And in this case, I think it's quite important one API. And this API is almost impossible to build on your own. I will try to explain why and what is it. Basically, traces API, it's blockchain logs that you will get if you will try to execute any EVM transaction. Ethereum virtual machine do have it's basically a virtual machine, and every transaction actually is a computation. And when you get the results of this computation, you will have some logs. If you will try, there are some things called events, for example, blockchain events. We have it in the ERC20 tokens sometimes, and it's basically also logs. The problem with events is that these logs actually are it's a feature and problem at the same time. Events are created by developers of smart contracts, and sometimes developer can forget to make such events, like to implement these events. And in such case, you will not have events in some transactions. And the main problem here is that if you, for example, want to build some analytics, let's imagine you want to get information about all users' transaction history. And user will make several transactions to make swaps. In such case, potentially there will be no events there. If there will be no events there, it's very hard to get information what user actually swapped. It's really hard to build, to get information what was inside this transaction in such case. And if you want to get real data, what was the transaction result, what was the return amount that user actually got, you need to use traces. You need to make a trace call. You need actually to debug this transaction and to see every function called inside this transaction, and to see the arguments and the state of this transaction. And using trace, basically to make a trace, you can use JSON RPC node. And the problem with that is that if you want to use a JSON RPC node and to make a trace, this JSON RPC node must be archived node. And if you want to run archived nodes, it's extremely heavy node. It requires several terabytes of data to sync. It requires pretty powerful like machines to run, and usually any archive nodes required like up to a couple of $1,000 per month of maintenance. But if you want to get information about multiple blocks, about multiple users at the same time, you need not only one node but multiple of them. So you need to scale such thing for several nodes, and it's already extremely expensive. So if you want to get a traces data with very high requests per seconds, it's extremely expensive. And what is the solution that we propose? We actually do everything on our own. We index almost 8 EVMs, all the traces of it continuously. So you have information about every trace inside each block, all the calls, all the logs, all the events inside. And it's also pretty low latency. If you will try to do trace on your own, it will make up to a couple of minutes to execute such trace. And with us, you have like almost 1 second or sometimes slower. So you get the same data with like 1000x performance, and you also don't need to maintain the nodes and to run it. That's the main feature of it. The problem is that to run a Hive node of Ethereum or like a Polygon, for example, is extremely heavy and almost no, like it's very hard for any project that is not focused on indexing on analytics. And it is really hard to get such data, and because of that, it's really hard to get a good analytics for some products. And if you don't have a good analytics, it's really hard to make some decisions to build a good product, basically. And without a good product, you will have no users. So it's basically a pretty large chain of events happening. So this is how Traces API looks like. The feature of it is that we don't only collect traces across all the blocks that we have already, that we are mined already. We do it continuously. So basically, let's imagine you made a swap and there is a new block and you want to get a trace of it. You can also use managed traces for that because we already indexed such transaction. We already have a trace for it. But sometimes you need to check that it was already indexed. And for such thing, you have a synced interval. Synced interval is actually a handle that allows you to see the latest block that was synced in our API. And you basically have a quite simple handles for getting a trace. We allow you to get trace by block or by specific transaction. The problem here is that if you will try to get a trace by block, it can be a bit big. Sometimes it's 20, 30 megabytes. So it depends on your use case. You just need sometimes a trace of one transaction or sometimes of the whole block. Depends on your scenario. So yeah, this is an example of how the trace looks like, how the execution looks like. It's basically the block, one of the newest blocks of Ethereum. We have some data on top of it. It's a type of this trace, the version of this trace, and the hash of this block. And we have a list of transactions there, of all traces of all transactions, and we have a bundled events there as well. All this data is actually quite expensive to get on your own, and this data allows you basically to build any analytics for your app. For example, if you want to build transaction history, you want to build your own transaction indexer, you want to get information how much swaps was and how much subpars was in one swap. Like depends on, with traces, it's like the maximum amount of data you can get from the blockchain. It's not only information that's stored there, it's the results of execution of every transaction. Such data is not actually stored inside blockchain. Every time you want to get it, you need to rerun this transaction on your own. And because of that, it's extremely expensive. And we already rerun almost every Ethereum transaction, and we just get the cache data for you, so it's much more cheaper and faster. Yeah, right here I have a core code for the Managed Developer Portal 101. All the API I told before, all of them are available right now to try in the code as well. We have a GitHub repo based on Node.js where you can actually see all how you can make a swap with examples. The minimum requirements there is just to create your own private key and create a private key for developer portal to make requests, but it's almost minimum requirements to start on it. You can use it, for example, for your examples to play with that. If you will building something, it's like there are multiple examples how to use APIs there. We will soon have an SDK, so it will be even simpler to use it. So thank you for your attention.
So Nick Kozlov, that was brilliant. Nick, congratulations. Do we have any questions for Nick? Yes, one question.
Yeah, thank you for the talk. Is it a paid API or it's free?
We do have a free tier, so you can use a free tier for every type of the API. We have a limits for that. It's 1 RPS per second. In some cases, for example, in traces, it's quite reasonable. Basically, you just need to wait for 1 second for the new block. The blocks are actually mined faster than, like, not faster than 1 second. So yeah.
Okay, okay. Thank you.
But we do have we have a paid enterprise plans, and we will soon have more extensions. So if it's not enough for you to have a 1 RPS, you can actually pay a bit and get more limits.
Reasonable.
Yeah, pretty obvious. Yeah.
Any other questions? No, well, I think, Nick, that was great.
Great.
A round of applause for Nick. Really awesome.